We are going to study different sets of numbers and the difference between them. Now, the lesson for today is sets of numbers. Okay, within the sets of numbers, there is a set which is called natural numbers. Natural numbers its symbol is this one. When you see this, it means it is natural numbers. It is a set of natural numbers. Now, what is a set of natural numbers? A natural number are numbers which are used in counting. Then when you are going to count things, you will start from 1. That's why the set of natural numbers it starts from 1, continue to 3, 4, etc. We will continue up to infinity. So that the set of natural numbers are counting numbers. That's why when we are counting, we start from 1, 2, 3. Consider that we are going to count trees. Within counting trees, we don't start from 0. We start the first 3. So that we say 1, 2, 3, 4, etc. This is a set of natural numbers as the first set. The second, it is a set of whole numbers. When we say whole numbers, they are numbers which does not contain a decimal point. The set of whole numbers. Its abbreviation, we use W to symbolize whole numbers. So that within the whole numbers, it is a number which does not contain a decimal point. And here, we can now add a 0 from natural number to get a whole number. So that the set of whole numbers, we start from 0, 1, 2, 3, and you continue like that. Many people confuse set of natural numbers and set of whole numbers. Remember that within the set of natural numbers, there are numbers we use in counting. We count from 1, 2, 3, 4. But within whole numbers, we add a 0 because a 0 is not a decimal. Okay. Number 3, it is a set of integers. Set of integers. The symbol we use to represent integers is Z, like this. Set of integers. Now, when we say integer, what do you understand? An integer is a whole number first. They include negative whole number, positive whole number, and that will include 0. Means that within integers, we start. There are many numbers which are negative. -4, -3, -2, -1, continue 0, +1, +2, +3, and so on. Then, remember that this is a whole number, but it is negative. Also, this is a whole number because it does not contain a decimal point, and it is negative. And within integers, they are whole numbers first, and they are negative or positive, and we put a 0. As you have seen that the whole number there is a 0, 1, 2, 3. What does it mean? It means that a natural number can be observed in integers. Also, a whole number can be observed in integers. Okay, let us continue. Another set of number. Okay, continue. It is number 4. Number 4 is rational numbers. Rational numbers. The symbol we use to represent rational numbers is Q, like this. Wherever you will get Q, which is written like this, it means it is a rational number. As you have seen here, the word rational comes from ratio. When we split by here, we get a word ratio. When we say a ratio, it is like A to B or 1 to 4. This is a ratio. But let us continue. When we say rational number, what do you understand? A rational number is any number that can be written as a fraction. A number which can be written as a fraction is a rational number. For example, there are some examples of rational number. For example, when we write 4, this 4 is a rational number because this number can be written as 4 over 1. In that case, this does not to be different as this, so that this 4 and 4 over 1 are the same. But this is a natural number. It is also a whole number. It is an integer, but it can be written as a fraction. So that this is a ratio as 4 over 1 or 4 to 1. This number is a rational number because it can be written as a fraction. So that you know that the fraction contains two parts where there is a numerator and the denominator. So that any number that can be written in this form is a rational number. Another example, when we write 1.333 continue, other numbers are 3, means that 3 will continue ever. This number, because it is a continuing decimals, recurring decimals or repeating decimal, is a rational number. Because any number which is repeating decimal can be written as a fraction, as a numerator over denominator, as a numerator and denominator, like that. So that this number can be written as this to get, when we write, for example, let's see, 10, no. For example, 1 over 3, is it? No, it is not like that. But within the next lesson, you will see how we can write this number as a fraction. We will see them. But remember that when we write 10 over 3, this is a rational number because this number this is the numerator and this is the denominator. And you know that this number, when it is written in decimals, we get that it is 10 divided by 3 to put here a 3. We write here 9, take away, we get a 1. We put here a decimal, we add a 0 here, then you will get 3, which will continue. No, we get 3 here, which will continue as that. So that a 3.333 continue, it is a rational number because this is a repeating decimal. Okay, number 5. Another set of number is irrational number. Irrational number. Set of irrational number. Some they use abbreviation like E, other they use other symbols, but irrational number does not have its appropriate symbol. And the set of irrational number, as you see here, a rational number and irrational number, they are two words where one it is an opposite of another. So that, as you have seen for rational number, as a number which can be written as a fraction, irrational number is any number which cannot be written as a fraction. For example, when we write a square root of 2, we get that a square root of 2, it is a number which contains a decimal point, but which are not repeating. Then it is a number which will not end first. A number which will not end, and their decimal are not recurring, they are not repeating. This number is irrational because it cannot be written as a fraction. Another number, as an example, is a number which is called the p. Some people say that p it is equal to 3.14, but it is not complete. It is 3.14 and other decimals there, which we not repeating. Another number, it is any square root of a prime number. Any square root of a prime number is irrational. It is a rational number. Number 6, which will be the last, it is a set of real numbers. Set of real numbers. Its abbreviation is R, like that. Now, any number that can be seen on a number line, any number that can be seen, that can be presented on a number line, it is a real number. Within these numbers, there are rationals and irrationals. So that's why we say that rational number, it includes, real number, it includes rational and irrational. So that all rational number and irrational number combined together yield real numbers. So that any number that can be presented on a number line from negative infinite to plus infinite, any number that can be put here, it is a real number. Within real number, they are repeating decimals, they are non-repeating decimals, they are natural numbers, they are decimal numbers, so that any number that you can think, it is a real number. Okay, to conclude this lesson, let us see how one set can be in another, so that one set is a subset of another. Which one is smaller, which one is bigger? So, to get a conclusion for this lesson, let's see. Okay, we said that we have a set of natural numbers. A set of natural numbers, we have seen that they are numbers which we use to count. We count from 1, 2, 3, 4. And we have seen that within the whole numbers, we take the natural number and we add an element which is 0. So that the natural number is shorter than the whole number. Because the whole number is the bigger than natural number. So that we take a natural number plus 0. When we say natural number plus an element which is 0, in that case we get a whole number. In that case, the whole number is the bigger than the natural number. Okay? Another set, it is a set of integers. Set of integers. Whenever we say integer, we understand a whole number which are positive and negative. So that within integers, some of people, they take integers and split it into two parts. Positive integers and negative integers. Together they give integers. Because here when we say positive integers, we understand only negative numbers which are whole numbers. When we say negative, we understand the numbers which are negative, but which are whole numbers. So that the positive and the negative integers, they give set of integers. Okay. So that after this, another set of numbers which is bigger than integers, it is rational numbers. Rational numbers, it is set Q. And we know that within rational numbers, we get all of these numbers which are here. They are irrational numbers. And we have seen that rational number together with irrational number, they give real numbers. The last set is real numbers, a set of real numbers. So that if this is a set of rational number, the set of irrational number cannot come inside the set of rational, because two sets, rational number and irrational number, they does not have intersection. So that here we can have rational number or irrational number together. Rational number and irrational number together, they give real numbers. Okay, thank you to attend our lesson for today. Next we will see other operations within sets of numbers. Thank you very much.